Most people believe the universe is empty, but they are wrong, and the truth is far worse than silence. The universe is filled with places so extreme, so violent, and so alien that nothing we know could survive them. Today, we are going inside 8 of the most terrifying locations ever discovered, and none of them are fiction. We begin with something that should not be possible, a star smaller than a city that contains more mass than our sun. A neutron star forms when a massive star collapses at the end of its life, compressed down to roughly 20 kilometers across. At that density, a single teaspoon of neutron star material would weigh roughly 1 billion tons on Earth. A star this dense rewrites every rule we know. Subscribe to Noxar Flux so you never miss the stories science cannot yet explain. But within the neutron star family, there exists a subset so extreme it has its own category, the magnetar. A magnetar carries a magnetic field so powerful it reaches 100 billion Tesla, a number with no earthly equivalent. At just 1,000 kilometers from a magnetar, its field would strip the electrons from every atom in your body instantly. Matter as we know it would simply cease to exist, not through heat, not through impact, but through magnetic force alone. And that is just the first location, because what is coming next makes a magnetar look almost calm by comparison. Magnetars also produce starquakes, tremors on the surface that release more energy in milliseconds than the sun emits in 100,000 years. In 2004, a magnetar 50,000 light years away released a burst powerful enough to measurably affect Earth's upper atmosphere. Had that magnetar been just a few thousand light years closer, the consequences for life on Earth would have been catastrophic. Magnetars exist only briefly on a cosmic scale. After tens of thousands of years, the field weakens, and what remains is an ordinary neutron star. No trace remains of what it once was. One of the most violent objects in existence fades quietly into the dark. But the magnetar is only the beginning, because the next place on our list is something the universe itself seems to have forgotten. In the constellation Eridanus, there exists a region of space so empty that astronomers spent years debating whether it was a flaw in their instruments. The cosmic microwave background radiation is the oldest light in the universe, a faint glow left over from the Big Bang itself. Within this ancient glow, there is a massive cold region, roughly 70 microkelvin colder than everything around it, and it should not be there. One explanation is a supervoid, a gigantic, nearly empty region through which light loses energy as it travels, arriving colder at the other side. But a supervoid only explains part of the anomaly, and the remaining explanation involves something that should be impossible to detect. According to multiverse theory, our universe exists inside a bubble, and if 2 of these bubbles once collided, the impact would leave a permanent scar. The cold spot may be that scar, a frozen imprint of another universe that grazed our own billions of years ago. This theory cannot be proven or disproven with current technology, yet it follows logically from cosmological models that are taken seriously today. We move now to the Bootes void, a sphere of near-empty space, 330 million light-years across. If the Milky Way were placed inside the Bootes void, it would take light over 300 million years to cross it. Inside the Bootes void, you would see almost nothing in any direction, just the edge of the void glowing faintly, billions of years away. Cosmic voids are normal, but the Bootes void is so large that its existence challenges our models of how structure forms in the universe. 60 galaxies have been found inside it where there should be thousands, and no one has a satisfying explanation for why they are missing. There is something 250 million light-years away that is pulling the Milky Way, along with thousands of other galaxies, toward it. The problem is that it sits directly behind the dense center of our own galaxy, hidden behind billions of stars and clouds of gas. We are moving toward the Great Attractor right now, every second of every day, and we have been for billions of years. Infrared and X-ray telescopes that can see through the galactic dust have revealed a massive concentration of hundreds of galaxies at the source. The Milky Way is actually part of this superstructure, not outside observing it, but inside it and being shaped by its gravity. Some calculations suggest the known cluster does not fully account for the observed gravitational pull, meaning there may be even more hidden beyond our view. The Great Attractor is not a single object. It is a region of space so heavy and so vast that its gravity shapes everything within hundreds of millions of light years. We turn now to pulsars, rotating neutron stars that fire focused beams of radiation into space with the precision of an atomic clock. Some pulsars rotate hundreds of times per second, and each rotation fires those beams across whatever lies in their path. Tell us in the comments, if you could safely observe any of these locations from a distance, which one would you choose and why? Anything caught inside a pulsar beam receives a dose of radiation so concentrated that no shielding yet imagined could survive it. What makes a pulsar so unsettling is not its violence, but its precision. It does not destroy carelessly, it simply does not notice you at all. There is a planet in our galaxy that is darker than coal, darker than black paint, darker than anything we thought a planet could be. It reflects less than 1% of all light that hits it, and what it does emit is the color of cooling iron heated to 1,000 degrees. The moon reflects about 12% of sunlight, black acrylic paint reflects 6%, this planet reflects less than 1%. Its atmosphere contains gaseous sodium, potassium vapor, and possibly titanium dioxide, compounds that absorb light before it can reflect back.
Despite being almost invisible, it is not cold. Its proximity to its star heats the atmosphere to over 1,000 degrees Celsius. It is the opposite of what intuition suggests. A planet this close to a star should blaze with reflected light, but it gives back almost nothing.
Even with everything science understands about atmospheric absorption, no complete explanation exists for why this planet is this dark. Everything we have seen so far is violent and extreme, but none of it compares to what we encounter next. A black hole has no surface, no wall, and no visible boundary, and yet it is the most absolute destination in the known universe. The event horizon is not a physical wall, it is a mathematical boundary beyond which the escape velocity exceeds the speed of light. From a safe distance, you would watch an approach to the event horizon slow, redden, and appear to freeze at the edge without ever arriving. From your own perspective, crossing the horizon would feel like nothing at all. No signal, no impact, no moment of realization.
What comes after the crossing is where physics as we understand it completely breaks down, and no equation survives the singularity.
Tidal forces increase until the difference in gravity between one end of any object and the other stretches it into a strand of pure matter. At the singularity, general relativity predicts a point of infinite density where space and time lose all meaning, and physics simply stops. Supermassive black holes at the centers of galaxies can reach billions of times the mass of the Sun, their event horizons spanning billions of kilometers.
Stars near a supermassive black hole orbit it at thousands of kilometers per second, their paths controlled entirely by the gravity of the central darkness.
And yet we have seen one. We have an actual image of the shadow of an event horizon captured by a global network of telescopes working together. That image, a ring of light around a circle of absolute darkness, confirmed that event horizons are real and not just mathematical abstractions. We end with something that, according to our best models of cosmology, simply should not be able to exist at all. The Hercules Corona Borealis Great Wall is a filament of galaxy clusters roughly 10 billion light-years across, the largest known structure in existence. The problem is that the universe is not old enough for gravity to have assembled something this large from smaller components.
Its existence suggests either our understanding of large-scale structure formation is incomplete, or something happened in the early universe we have not yet explained.
A structure that should not exist, spanning 10 billion light-years, is not the end of this story, but only one piece of a larger picture. Each location we have visited today exists within this same universe, the same one that contains our planet, our star, and everything we have ever known. The universe we live in is not a safe or gentle place. It never was, and understanding that changes how we think about our own existence. What is remarkable is not how dangerous the universe is, but how fortunate our corner of it appears to be, at least for now. A magnetar within a few thousand light years, a pulsar beam sweep in the wrong direction, any number of cosmic events could reshape this planet permanently. This is precisely why space science matters. Every discovery about these extreme environments tells us something about our own position and our own future. The observable universe contains roughly 2 trillion galaxies, each with hundreds of billions of stars, and we have explored an infinitesimal fraction of it.
Every new telescope, every new observation pushes the boundary of what we know, and almost always reveals something that resets what we thought we understood.
Even in a universe full of these terrifying extremes, the same forces that create magnetars and black holes also build the stars that warm planets like ours. The violence and the beauty of this universe are the same process seen from different distances, and we sit at exactly the right distance to see both. The magnetars, the voids, the event horizons, the Great Wall, they are all part of the same universe that produces this view from a mountain on a clear night. We have covered 8 of the most extreme locations in existence today, and each one is connected to an even deeper question about what the universe is. The terrifying truth is not that these places exist, it is that our understanding of why they exist is still incomplete, and that gap is where science lives. Subscribe to Noxar Flux so you never miss a story. Cosmic terrors and deep space mysteries drop every single week, only here.